All right, welcome to our second part of our video. So now we're going to start looking, where we start to see some more of those prep work steps happening. The focus of this prep work, though, is when you have variables on both sides of the equal sign. So either way, I'm going to draw my wall. And I already know what the prep work is going to be, but I'm still going to look for all three steps. So first I want to look for parentheses. I don't see any. I want to see, can I combine these? And they are not like terms. Same thing over here. And so this third step of prep work is going to come into play. I don't need an x term on both sides of my equal sign. I just want it on one side. So I have two choices. One is I can move 13x over to here, or I can move the 8x over to join 13x. And in the end, it really doesn't matter which one you move, but I always think there's a better one to move. And that's the one that's the smaller in value. And that would be the 8x, because 8 is smaller than 13. So I'm going to move it by subtracting. And maybe you're thinking, oh, wait, shouldn't she be adding that because there's a subtraction sign? Well, let's say you did add 8x. If you have 8x and you add 8x to it, you haven't gotten rid of it. You've just made more of an 8x. So I'm going to erase that. It's not a very good eraser. And subtract 8x here. And I'm left with subtracting 47, or I want to think of that as negative 47. Let's see. Hold on. Let me put on this light. I don't think that helps much. And that means I'm going to add 8x from its like term, not the 48. So 13x, take away 8x. That means I just have 5x left. Still have the 48. And now I'm to a two-step equation. So it'll only take me 2 steps to isolate x. And these will be, for now, our 2 steps. So first I'm going to move the addition subtraction. They added 48. I'm going to subtract 48. And negative 47, take away negative 48. That is kind of a big number. So if you need your calculator, type in negative 47, take away 48, and you're going to get negative 95. And now to solve for x, last step, I'll undo that multiplication with division. So divide by 5, divide by 5. And again, if you don't know what negative 95 is divided by 5, just, oh no, there's that glare. Just type it into your calculator. It's okay. Try to do it without the calculator, but if you need that double checking, feel free. All right, next problem is going to have the same idea. So first I will look for parentheses. I don't see it. I'll try to combine like terms. They're not alike. Combine like terms. They're not alike. And so now what I need to do is just the third step of prep work is move this x to join the 5x, or this term to join the 8x. And it doesn't matter, but I always like to move the smaller one. So I will subtract 5x. It's gone. Subtract 5x with its x term. So I get 3x. I still have the 12. And now subtracting 21, I really should think of this as negative 21. And now I've got my 2 steps. So I'm going to do my addition subtraction first. They're adding 12. I'll subtract 12. And negative 21, and I take away 12 more. If you start out with negative and then you take away more, it's just going to have even more negative. So that's negative 33. And now to solve for x, I'll undo that multiplication with division. Divide by 3, divide by 3, those cancel out. And I have negative 33 divided by 3. That's going to be 11, and since it's a negative divided by a positive, you get negative 11. All right, let's take a look at a few more, and then I'm going to let you, actually just 2 more. And then if any of you have thought this is relatively easy, and you're like, I got solving down, we're going to have an extension. So the next video you're going to see is purely optional. You do not have to watch it. Maybe you want to watch it just to see what it's like, but we won't be solving and getting x as a number. We'll be rearranging equations. So it's a really good skill to have, but for now we're going to put that on the back burner. So again, prep work, draw my wall. So no parentheses, no parentheses. Second step, no like terms, no like terms, so I won't combine. So now I need to move one of the x's. So I kind of want to think of this as a negative 1x, or subtracting 1x and subtracting 2x. And this is the smaller in value. So I need to move this to join this. And so to undo that, I'll add 2x since they subtracted 2x. And if you're subtracting 2x and then you add 2x, that just cancels out. I'm going to add 2x and almost think of this as a negative 1x, and then I add 2x. That just gives me 1x. And you technically do not need to put that 1 in front of the x, but you can if you want. All right, moving right along. So now I've got my 2 steps. I'm going to move my addition subtraction. That's the 15. So I'm going to subtract because taking away 15 gets rid of it. When I drop this down, I'm just going to turn it into x because remember, 1 times anything is whatever you're multiplying by, so it's just x. And 23 take away 15 is 8. There we go. Last one. Again, you're going to see the pattern of there's no parentheses, cannot combine, and I cannot combine. That's my second step of prep work, but I can do the third step, and I want to get the x to one side. So between this term and this term, I will move the 4x because it's smaller. So the only way to get rid of a positive 4x is to subtract 4x. So when I subtract these, I get 2x. And just one thought to bring out there. Some people might say, well, if 6 take away 4 is 2, then shouldn't this x take away the x? Shouldn't that be gone? And what you need to think of this is that this is saying I have 6 x's, right? And I'm about to take away 4 of them. So I'm just getting rid of them. So when I'm done, I still have x's. I just want to see how many I have left. So that's 2x. All right, let's go to our 2 steps. Addition, subtraction. They're subtracting 5. We'll add 5. So we get 2x equals 7. And now to undo that multiplication, we'll use division. So we're going to divide by 2. We're going to divide by 2. And we haven't had any big fraction or decimal answers, not that many. So again, it's okay to have a fraction. It's okay to turn it into a decimal. 7 divided by 2 is 7/2. I cannot simplify that fractions. That is as simplified as it gets. If you want to divide it like this and see what it is as a decimal, you can. And let me just show you one little trick on your calculator. This works on the graphing calculator, not at all. So I'm not going to use 7/2. I'm going to use a fraction that I know I can simplify into something else. So I'm going to take, let's see, oh, I can't even think of anything right now. Hold on. Let's take 12/8. So 12 divided by 8, that is a decimal answer. But if you, and again, you could leave it as 12/8, but one thing you can do on your calculator, so let me show a little bit more, is 12 divided by 8, and I get my decimal. But one thing you can do is actually have the calculator simplify this fraction for you. So once you get it into a decimal, what you want to do is come down here and press this math button. And what you'll see is, okay, it's saying here, do you want me to take your answer and put it as a fraction? And I'm going to hit enter for yes. So it's saying, okay, you want me to take this answer and make it into a fraction. And when it does, it gives you the most simplified fraction, because if I divide this by 4 and this by 4, I get that 3/2. So this has nothing to do with any particular problem on this page. It's just something to point out. All right, the next part of the video is if you want to see an extension, something to challenge yourself, great. If you're like, I'm good, you can stop here. So in this part, what we're going to do is, these are called solving for literal equations. And it means we're going to be solving so that instead of x equaling 8 or x equaling 3.5, we're going to be writing this so that y equals everything. Or in this problem, x equals everything. Or in this problem, m equals everything. So let's walk through some of these. My prep work is still going to be the same. I'm going to first look for parentheses. I don't have any. I'm going to look, can I combine these? And although they both have a variable, they're not alike. So I can't combine those. There's nothing to combine over here. And as far as getting the variable on both sides of this equal sign, that's if they're the same variable, like x. So my goal here is just to get y alone. So what I like to do is kind of just circle the one that I'm trying to get alone. And since there is no prep work, I'm just going to work backwards in my order of operations. So to get the y alone, I need to move 3 and I need to move 6x. And so what I'm going to move first is this addition subtraction. So compared to the y, they're subtracting 6x, so I'm going to get rid of 6x. So since they subtracted, I'll add. Those cancel out, and then I'm left with 3y. I'm going to keep that y circle very lightly. And then I have 12 plus 6x, and these are not like terms, so I can't make it 18 or 18x. I'm just going to write out 12 plus 6x, just like I'm saying it. And now to get y by itself, I'll move the 3, and since it's multiplied, I'll divide. So there's two ways you can do this. There's the simpler way, and divide this whole side by 3, and divide this whole side by 3. And that's a great answer. You know, you could have y equals 12 plus 6x over 3. But if you're really looking for the challenge, what I would suggest you do is instead of dividing the whole thing by 3, divide each term. And again, terms are separated by addition and subtraction signs. So divide by 3 and divide by 3, because then you can simplify this. 12 divided by 3 is 4. 6 divided by 3 is 2. And then when we go to graph lines and you have it in the form of y equals mx plus b, this is a lot easier to graph than this. So just something to keep in mind. So in 12, draw my wall, and I'm going to get x alone. So again, there's no parentheses, there are no like terms here, 70's alone, so I can't combine those like terms. And since these are different variables, I don't need to get them on one side. It's, again, if they were the same variable, I want to combine them to one side. So to get x alone, I need to get rid of my addition, subtraction, my multiplication, division. You're going to see that's kind of the only steps we've done. So I need to get rid of the 2, the subtracting 6, and the y. So when I move the addition, subtraction, it actually really probably doesn't matter which one you move first, but I'm going to move the 6, so I'm going to add 6 since they subtracted 6, and add 6. Now these are like terms, so I can combine those. So on the left side I have 2x plus y, and now I add those and I get 76. And now to get x alone, I still have some addition, subtraction to move. They added y, we'll subtract y. Cancels out, so now I have 2x equals 76 minus y, subtracting y. Again, those are not like terms, so I can't make it 75y. And now my last step is to move the 2, which is multiplied to the x, so we'll divide it. So I'm going to divide by 2, and I'm going to do what I did over here. Instead of dividing the whole thing by 2, I'm going to divide each term by 2. Those cancel out. And now I'm going to have x equals 76 divided by 2. So again, if you need a calculator, get one. That's 38. And y divided by 2, I'm just going to put an not imaginary. It's actually there. There's a 1y. There's always a coefficient. That's called a coefficient when it's attached to the variable. And if you don't see a coefficient, it's 1. And then what I'll do is separate that out as 1/2 times y. All right, moving on. So if you're like, yeah, I'm good with that extension, again, there's no pressure to watch this. All right, m, let's solve for m. So I'm going to circle it. And so if you notice there's a negative there, so what I actually want to do is put a -1 there. Just rewrite it, because again, as I said, there's always a coefficient, a number attached to a variable. And if you don't see it, it's a 1. And in this case, it's a -1. And I'm going to circle the m. And my goal is to isolate m. So I got to move the -1 and the 2m. So again, no parentheses. I cannot combine these. These are not like terms. And since these are the same or different variables, I don't need to move one to the other side. So the addition, subtraction, I'm going to move the 2n first because it's adding. And on this side I have -1m equals 10 subtract 2n. Since these are not like terms, I'm just going to write it out exactly as I said it, but left to right. And now I'm going to undo the multiplication division, and I'm going to take this negative, divide by -1, so now I have m, and I'll divide each term by -1. So when I'm done dividing these, I get -10, and think of this as a negative divided by a negative, and you get a positive. Now m is isolated. All right, let's take a look at p. So again, p, I'm going to draw my wall, circle it, no parentheses, no like terms, and I don't need to worry about getting all the variables on one side, even though they are, because these are different. So the addition, subtraction, we're going to move first is the 6r. They subtracted, we're going to add. So I have 1/2 p equals 3. Whoops, I lost my plus sign there. Plus, there is a plus there, 3r. Whoops, sorry, 6r. So again, can't make it 9 or 9r. These are not like terms. And so now I'm going to get rid of the half. So again, when you take something, let's just something, and you divide it by a fraction. That's what we're doing, dividing by half. You know, these will cancel out because anything divided by itself is 1, and 1 times p is p. But what you learned in middle school is that you can copy, dot, flop. So when you divide by a fraction, you're actually just multiplying by the reciprocal. So I'm going to multiply each term, or I could think of it as the whole side, by 2. And then I should distribute that in. So 3 times 2, well, that's 6. 2 times 6r, that's 12r. And that's it. We cannot combine these. These are not like terms. So 2 more. All right, let's see. We get some challenges here. So h, I'm going to get alone. So the parentheses, sure, we can distribute the parentheses. Might as well just keep it that pattern. It's not the only way to do this problem. So prep work, distribute, distribute. So in geometry, this is the formula for the area of a trapezoid, and what they do is they have 2 bases, the top part and the bottom part. So this just means the first base and the second base. All right, so all of that's there, right? And that's still times the h. Oh, and actually, I take it back. I'm not going to distribute that one. We're going to do this one a little differently. What I'm going to do is, since I need to get h by itself, is I'm going to move the 1/2, and I'm going to move this whole parentheses. So what I'm going to do first is, I know there's parentheses, but there's every now and then there's exceptions to the rule.